Hello students, and welcome to the Solve by Factoring station. What you're going to want to do is grab one of those papers in the middle of the table, and then we're going to do one problem together. First thing I want to talk to you guys about is when to use certain types of factoring. GCF, or greatest common factor, what you're going to want to make sure you do is use that all the time. Always check, is there a number that all of them can be divided by? Or do all of them have an X that you can take away? So then you can put it outside the parentheses. But always make sure you check that before you start any factoring problem. Grouping is when you're going to have 4 pieces to a particular problem. Then you're going to put it in the box. AC method, we're going to do an example in the video. That is when you have 3 pieces to something. What we're going to do is multiply A times C to get our B term when we multiply, or when we add the two numbers that multiply to give what AC is. And then we're going to put it in the box ultimately. Difference of perfect squares, you need only 2 pieces. But there's just some things you need to have. Number 1, you need to have it so that they are both you need to have it so that they're subtracted from each other. And then you need to have so that both of the pieces are perfect squares. So either they're 25, 36, 49, something like that. One's going to have a minus in the middle, and one's going to have a plus in the middle. So what we need to do is figure those out. What we're going to first do here, though, is we're going to actually do a problem. 5x squared plus 5x equals 10. So the very first thing you need to always make sure you do is make sure they're all on the same side. So I got 5x squared, 5x, and equals 10. They're not all on the same side. So I'm first going to subtract 10 from both sides. And I'm left with 5x squared plus 5x minus 10 equals 0. So now I can actually start to factor my problem here. But first things I notice, always check for that GCF. I notice all of them have a 5 in common, right? So what I'm going to do is pull out or factor out that 5. So now what's going to be left behind after divide by 5? So 5x squared divided by 5 is going to leave me with a 1x squared. 5x divided by 5 is going to leave me with a 1x, and negative 10 divided by 5 is going to be leave me with a negative 2. Now what I can do is I can factor the inside of these parentheses. Now it's 3 terms, so I know I can use the AC method. So I'm going to go A times C. So my A term is who's ever with the x squared, which is our 1. And our C is who's ever with no x, negative 2. So 1 times negative 2 is negative 2. So then I need to list all the different things that multiply to give me negative 2. Well, that's a pretty short list, isn't it? 1 and negative 2 and negative 1 and a positive 2. So what I need to now do is add these together and see which one of these, when I add together, is going to result in the B term, or the one that's with the x. So I'm looking for 1. 1 minus 2, well, that's negative 1. And negative 1 plus 2 is 1. So I'm looking for this one, right? Because that gave me my 1 that I'm looking for. So now what I can do is use the 2 numbers I found and rewrite this middle term. So I got 1x squared. Now I can go back over here, minus 1x plus 2x minus 2 equals 0. Notice these two are that. If I would combine, that's what allows me to do this. So now I have 4 terms inside my parentheses. I can now use grouping, or the box method. So let's put every single one of these pieces inside the box. Notice the 5 just kind of hanging around for the ride. So I got 1x squared, negative 1x, 2x, and a negative 2. So now I can pull out GCFs. What is the GCF of these two? Well, I notice they're both 1, and I'm going to leave the negative for this column because they both have a negative there. They both have also an x, so let's pull out an x as well. these two here, looks like they don't have any numbers in common except for a 1, and then they both have an x. So we're going to pull out 1x out of there. These two, looks like they both have a 2 in common. And then these guys have just a -1 in common. So what I'm going to do is now write my factors around the edge. So I got 1x minus 1 and 1x plus 2 equals 0. So now what I can do is set each of my pieces equal to 0. So I got 5 equals 0, 1x minus 1 equals 0, and 1x plus 2 equals 0. Because I'm solving, I have an equal sign. Well, 5 can never equal 0, so we don't even care about that. That would be if there would be an x on the outside. Always watch for that. A lot of students forget about it. Solve for here, I would add 1, so I got 1x, or just plain old x, equals 1, right? Here, subtract that 2, so I'll get x equals a -2. So my answers for this particular problem, x equals 1, x equals -2. So now what I would like you to do is complete the rest of the problems on the rest of this worksheet. As your group is finished with all of them, go ahead and open the envelope in the middle of the group and check your answers. If you have any issues, call me over. See you later, Sabers.